Today's job is ancestral state reconstruction on a phylogeny. Now I always use base traits for this job, but today I'm trying something a bit different. I'm trying the core HMM approach. Now this is an R package. Now installing R packages is always a bit of a headache, but this needs to be done. So very briefly, to install the core HMM R package, this is what I went through. I used a slightly newer version, well, a newish version of R, version port 4.0.5. Before there's a library, something outside of R you need to install. It turned out I had to install this, and then go into R, and you can try install packages core HMM, and you can add dependencies equal true if you wish, but that's unlikely to work on its own. I had to obtain a couple of slightly older versions of these packages, these dependencies, otherwise because the existing on the repository it won't run on this version of R, even though it's not particularly old. But anyway, you'll often encounter this issue. What you need to do is go to this link here and find something. For example, if you have a version of R which is like a couple of years old, then check the dates and get a version of the package which is also roughly about the same time, and that should install. And that's the trick to doing that. If you have, so you'll try install this package, and it will say it's not successful because dependency X is not available for your version of R. So for these dependencies, go and get these off this website and install them separately yourself. You just download the package, put it somewhere, and then install package using a path where you store this package, and then try again, and then you should be successful. So that's what you had to go through. So as I say, it's always a good idea to have multiple versions. As you get on a bit, say 5 years of using one version of R, you'll probably need to install. But I wouldn't recommend removing an old version of R, or you lose everything you put on there. So you can install multiple versions of R. Is a trick to this, and you launch these on under the appropriate path. Then load the core HMM library. Read a tree. I didn't seem to have any issues with getting a certain format of tree. So the main issue is, now this is something which really should be in the documentation. So this word, I don't even know how to pronounce it. I'm going to say vignette. So you get a vignette for each R package, which is like a walkthrough. Now there's something important missing from this walkthrough, and that is the format of the trait data. So let's read the trait data in. And let's take a look at it. Now when you're reading any tabular data into R, if you have missing data, the convention in R is to have NA as a missing to denote missing data. But for this package, you need to use question marks. So this will cause you some confusion because this is not stated anywhere in the vignette. It should give the format of the data, input data, but this is indicated in the function. Launch the help page to the main function in this package. So you can see in the help page, it does tell you the format of the data. So you need to do question mark. So that's the main thing. Just make sure in your input table for the trait data, if you have missing data, which I've never had an analysis where there's no missing data for traits. It is quite unlikely for most. So, but you need a question mark, not NA. So that's the main thing, and it will, if you have NA, it will crash and it will not tell you why. But that's the main issue to figure out. But apart from that, so read a table and some minor processing which may be required or may not. I'd recommend ordering. I'm not sure if it's required, but it's good to order your data table in the same order as your tip labels. I would usually do that just in case. But here's the main function for ancestral state reconstruction with a hidden Markov model. Core HMM, you need the phylogeny, the data table of the traits, rate categories. Now this is the cool thing about this method is it allows for changes in rate of the evolution of the traits across the tree. But note it quickly gets very slowly as you increase the number of rates. Model and a bunch of other things. A number of cores. This is quite confusing. If I set this to 1, 2, 3, or 4, then 6 cores are used for some reason, and if I set it above 4, then 8 are used. So I'm not really sure what. That's a bit of a puzzle to me. And do you want tip states? I'll put it as F, and then so you run this, and then as it's a bit slow, I've done this already, and I've used the save image command. So when you turn your computer off, you can next time you don't need to repeat it. Then you just load the thing, and the main variable is the main result is this. So you can see the rates, transition rates between states on your phylogeny. So in this case, we have 3 states for this trait. And the main thing we want to do is we want to plot. Now in the there's another issue here. A documentation, the default is to print something which I don't think is particularly useful. So this is this is the most likely state at each point in the phylogeny. Now that it gives you the most likely state, even if it is not significant, even if there's actually no evidence or no signal of the state. So this is a bit misleading, really, unless you have a really particularly easy challenge. It's more likely that a lot of these internal nodes cannot be reconstructed, and this I don't think is particularly useful, this plot. Instead, I would do standard phylogenetic plot, and the thing is to print the probabilities of each state for the internal nodes, and here's commands I found to do this. So plot phylogeny and plot node labels on phylogeny, and we're going to plot the pie charts to denote the probabilities. Now I've done this. I used some custom code to do this elsewhere here, but there's some quite convenient and quite useful. Probably I presume this is Ape, which is doing this. So let's try and run this and see what we get. So this phylogeny is about 1,500-ish, and we have the pie charts denoting the probabilities of each of the 3 states. So you can see in some cases reliable state assignment, and other cases which we don't know what the internal states are. So very good. And the only other thing which is good to do would be to plot the transitions. So we have plot MK model to plot the rates of the transitions between the states, which is something. Now, there's one issue with this is it numbers the states rather than telling you what the states are. States are here. We have M, O, P. Now it's numbered these. It would be more useful if you just gave the names of states, because we don't know what is 2. Well, we need to look at this here. It'd be useful if it just had M, O, and P here. And I haven't figured out how to change this at the moment. I'm not sure. This is not really shown in the documentation, but and in the case we have the 2 is O, which stands for oligolecty. 1 is M, monolecty, which is a kind of host range in bees, and 3 is polylecty. So these are bees which are visiting a lot of different flower species, and transitions between these. In any case, job done. That is a quick guide to using the Hidden Markov Model approach in R to reconstruct ancestral states on a phylogeny. Job done.